An important part of developing a child's understanding of mathematics is counting on from 5. What that means is a child can unitize 5. Every time he sees 5 or any symbolism of 5, he knows that it's 5. For example, a child with his hands would have to realize that when he holds one hand, there's always 5 fingers. So if you ask kids how many fingers they see when they see this, for the first time they will count every finger one at a time. It's important to point out to them that in one hand, there's always 5 fingers. You want them to move from counting every finger one at a time to unitizing 5 and counting the 2 extra ones. When a child begins their understanding of unitizing 5, they will need to realize that after 5, there's 6 and then there's 7. So they will be counting the extra 2 or the extra 3 if you're counting to 8, or 9, the extra 4, or the 5 and 5 to 10. In a classroom settings, you may have kids who already know this and some who don't. Therefore, your level of activities will have to be differentiated amongst the kids in your classroom. For students, a good manipulative would be to use linking cubes. And in the linking cube setting, you want, again, to unitize 5. Hence why you would use 5 of one color and 5 of the other color. And you want to point this out to a child in your classroom that there is always 5 of one color. You're not trying to trick them. So when you break up a linking cube like that and you ask them how many little cubes do they see, you'd want them to not start at the beginning and go 1, 2, 3, 4, 5, 6, 7. Rather, you'd want them to see 5 and count on from 5 and say 6, 7. With lots of practice, when a child sees this arrangement, he will know it's 7 because he will have unitized this part as 5 and this part as 2 and combine them together as 5 and 2. Activities to do this with is just to play a pull game where a child takes one end of the linking cubes and breaks it, and you ask them how many cubes they see. You can do that with both ends of the train. If they see 3 cubes, they should be able to say 3 just by looking at it and not necessarily counting. Once they're done with the linking cubes, you can move on to other activities, such as a 10 frame. If you want a child to represent 7, for example, you'd want a child to know that on the top there's always 5, and 6, 7 would be 7. A kid can start by writing it on the 10 frame and realizing that for 7, that's what the arrangement would look like. If you don't want to tell them the number to put on the 10 frame, you can do a few things. You can have them pick out playing cards. So for example, if they pick out a 4, to represent 4, they would know that 4 is 1 less than 5. Hence, 4 would be represented this way. If they picked out another card, such as a 7, again, they would do their 5, 6, 7. Students will have to play with these kinds of activities for quite some time before they can really unitize 5 and count on from 5. If you don't have playing cards or you want to vary the playing cards, you can always use a place value dice, where all the numbers from 0 to 9 are included. So when a child rolls, say, a 3, well, he would represent a 3. Again, realizing that 3 is 2 less than 5. He can also roll, again, your 7, which is your 5, and 2 more. It's very important to watch for kids not to put little dots 1 on 1 in counting the 5. So at this point, you want students to realize that the top row always has 5. Hence, they don't need to count. They know that. And they can count on to what they know. If you want to verify that students have mastered counting on from 5, you could show them 10 frames and ask them how many do they see colored. Students who don't have mastered counting on from 5 will need to count and won't realize that 5 and 4 is always 9, or 9 is 1 less than 10. If a kid can say 9 right away just by looking at the arrangement, chances are they're starting to really solidify their understanding of 5 and of counting on from 5. The other card could be 8, which is 3 more than 5. And you may want to point it out to kids or ask them why they know it's 8. And really have them verbalize that 8 is 3 more than 5. It's very important to vary the activity so the kids really get the math concept and don't get hooked on the actual model that they're presenting with. Another representation for counting on from 5 would be the use of a reckon rec, a 20 reckon rec. The idea here is again to get kids to represent numbers. And if you don't want to have to tell them which number you want them to represent, you can always give them cards. So for example, if a child picks a 3 card, they would take 3 and move them over. At the same time, they're realizing that 3 is 2 less than 5. They're also realizing that 3 and 5, 6, 7 must make 10 because they know that 5 red balls and 5 white balls makes 10. Another example would be if they wanted to represent 6. 6 would be represented by moving all of the 5 white balls and 1 more, because 5 and 1 more is always 6. If you see a child counting each ball as they move them, 1, 2, 3, 4, 5, and 6, you have to realize that that child hasn't already unitized 5. And that's something that he or she will need to work on over the next little while before they can do this efficiently. Although if you play enough and you try to tell them, well, please don't count. Just try to look at them and see what 6 would be like. Is 6 bigger than 5? Is 6 smaller than 5? Those questions are all good questions, leading the child to understand the mathematics behind the tool, which is really key to this particular representation tool. So in your classroom setting, everybody can have one of those things, and everybody can be representing different numbers if they all have their different sets of cards. They don't all have to present a number that you're telling to the entire class at the same time. And different kids can be using different representations at the same time also, depending on where they are in their progression. It'll be very important to walk around to see really what kids are doing with these representation. Are they counting? Are they not counting? Can they unitize 5? Can they not unitize 5? Those information will guide further instruction. To verify that students really understand unitizing, you want to give them a more abstract version of the linking cubes that they can look at and see if they can tell you how many they see without counting. Because they're not separate and they're on a piece of paper, it becomes a bit more difficult for students to get the accurate number of linking cubes just by looking at it. Therefore, for formative assessment, this would be a nice tool. A student, by looking at this card, should see that there are 8 linking cubes without having to count. That would be, again, a neat way to see if the student really gets it. And he should say 8 without a big period of time. Because if there's a big period of time, he may be counting every one of them by looking at them and moving his head. Usually that's a sign that a kid is counting if the head's bobbing while they're looking at a card like these. There are different versions of them, and starting from one end or starting on the other end is also a good example to see if they really understand they're unitizing 5 and they're counting on from 5 just by a glance. And that's the ultimate goal of counting on from 5, is for students to be able to tell you how many there are without counting each one as a separate unit. Another representation for counting on from 5 would be to use money. For this, one has to realize that students need to know what a nickel is. A nickel being a unitized version of 5 cents. At this point, a nickel is very abstract for children because they cannot see 5 things in a nickel. They have to assume that it always is equal to 5. So having students play with money, and again starting with nickels and pennies, would be a good start to see if they could represent these numbers. So if you want students to show you 8, you'd assume they'd give you a nickel and 3 pennies. You can leave it like that and ask them to show you 9. What are they going to do? Do they realize that 9 is really just 1 more than 8, and that it's 1 nickel and 4 pennies, or do they not? That's a good indication if students understand the counting 1 more than opportunity here. Students, after they have sufficient practice with the nickels and the pennies, can then move on to paper money with the $5 bills and the loonies and the toonies. The reason why the $5 bill, once students have had sufficient time playing with the actual coins, you can even bring this more abstract version of unitizing 5 and counting on from 5 to a paper copy. Once they see this kind of card with a nickel and 4 pennies, they should see 9 right away. If they can, that means they understand that the 5 cents always means 5, and they can't see 5, they don't have an approach to count 5. Hence, it's a more difficult problem than with the 10 frames or with the linking cubes. And that's very important as an indication of unitizing of 5. Once they are done playing with the nickels and the pennies, or the 5 cents and the pennies, you can then turn into the paper money. And the reason why the paper money is more difficult is because they not only have to unitize the $5 bills as 5, but they also get to unitize the toonie little coin as meaning 2. Although it's 1 coin, the coin represents 2. So you're unitizing 2 different numbers in the same context, and that makes it more difficult. Let me show you an example of what you can do with the money. Here is the money. So here's a $5 bill, and again, students need to understand that this means 5 and it represents 5. Therefore, if I show them a $5 bill and a loonie, they should know right away that that is 6 without having to count anything. Well, there is nothing to count. One piece of paper representing 5 things is a very difficult concept for students, and again, it's a representation of what it means to unitize 5, knowing that one thing may mean 5 things. Activities that you can play with your students is asking them, by giving them money again, to show you different numbers. The interesting thing with money is if I ask you to show me 8, you can show me 8 with a $5 bill and 1, 2, 3 loonies, or you can show me 8 with a $5 bill, a toonie for 7, and an extra loonie for 8. Having students the chance to realize that there's more than one way to show 8 with the paper money compared to the coins when you work with pennies and nickels is very important. It becomes a problem-solving context for students. Therefore, asking them, is there more than one way to show me 8? Is there more than one way to show me 7? Is there more than one way to show me 9? Is there more than one way to show me 6? Always using a $5 bill, because again, the goal of the activity is to see if they can count on from 5. Once they manipulate these numbers really well, they'll start to understand and build confidence with the fact that there are many different ways to show different numbers, and that's the beginning of partitioning for these students. Partitioning meaning that one number has different sub-numbers making it. For 8, a 5, a 1, and a 2, there's also the 5 and the 3 making 8. Right? Those are 2 different combinations for 8. And there are many more, but that's the beginning of getting students to partition these numbers, looking at 8 as subparts instead of 8 as being just one whole part. Once they have played with money for some time, you can again bring them to a more abstract version of the same activity by showing them cards with pictures of the money, such as these one. Here you would see you have a $5 bill, 2 loonies, and 1 toonie for a total of $9. They should be able to look at that and say 9 without counting each part individually. So the ultimate goal will be for students to look at this and say 9 with very few seconds to think about it, and not going 5, 6, 7, 8, 9. Right? To look at the 2 and think in their head 5, 7, 9. That's really the goal. And ultimately, once they're really have practiced this, they'll just look at this and say 9, like they've always knew it. And that's when you know a student really is able to count on from 5 without actually counting each piece separately. They can unitize both parts, the 5 and the 4, and know that 5 and 4 is 9. And that's, again, is the ultimate goal of counting on from 5. And students are able to say these numbers with very little thinking time, and definitely no counting each of the units individually.